Hello, everyone. I am Luis Aliendre, and with my colleagues today, Harshal Chalke, we are presenting EchoFrame, lightweight cardiac segmentation. With today's sedentary lifestyle, cardiovascular health needs heightened attention, and that's why we are proposing an architecture inspired from MobileNet V3 with an attention mechanism. And we would also like to enhance this model by adding dropout regularization and Monte Carlo sampling for robustness and uncertainty quantification. What we are trying to do is first segment echocardiogram videos and then estimate the left ventricle ejection fraction, which is a really crucial parameter for evaluating heart health. My colleague Harshal will continue with the next part.
Good morning, everyone. My name is Harshal. Moving on to introduction part, estimating left ventricular ejection fraction provides crucial insights into heart function. A healthy heart typically has EF between 50% to 70%. To quantify EF, we calculate the left ventricular volume at end of systolic and end of diastolic stages. Our dataset provides volume tracings for these frames only. Now the volume is determined by area of left ventricle and length from apex to mitral annulus, as shown in figure 1. As you can see, the formula for volume is 8 into a square by 3 pi into L. We will use this formula to estimate volumes at end of diastolic stage and end of systolic stage, which will help us calculate ejection fraction as given in the second formula. Now, moving on to dataset, my colleague Louis will take over from him.
It is crucial in order to make an application using deep learning, machine learning, or AI to have a data set first. That's why we focused on obtaining a publicly available dataset, and we were able to have two publicly available datasets, the EcoNet Dynamic and the EcoNet Pediatrics datasets. Both are from Stanford University Medical Center. And the first one, the EcoNet Dynamic, focuses on showing echocardiogram videos of adult hearts. It has more than 10,000 videos showing the apical four-chamber view, while the EcoNet Pediatrics dataset has more than 3,000 videos of pediatric patients also showing the apical four-chamber view. Each video includes segmentation coordinates for end systolic and end diastolic frames, but we are facing the challenge that we only have 1% of labeled data. Please go ahead, Harshal.
Yeah, adding on to point made by Lewis, we are only going to consider echocardiograms with apical four-chamber view in both echodynamic and EchoNet pediatric dataset. Now, as he said that we only have segmentation coordinates for end systolic and end diastolic frames, which account for 1% of label data as per paper 2. We have to figure out some way to augment the data set to have segmentation labels for intermediate frames surrounding ESV and EDV frames. So for that, we got the solution from paper 2 that we have to perform some affine transformations, that is scaling and translation by plus and minus 10% to simulate natural positional variations of a beating heart. And additionally, we also perform deformations, thin plate spline deformation, to replicate natural heart motion across the frames. So doing this, we have segmentations for intermediate unlabeled frames around end systolic and end diastolic labeled frames. Now moving on to experimental methodology, the architecture shown in figure 3 receives an input of current frame plus segmentation mask of previous frame. Now, with this input, it will make transformations to generate the segmentation mask for current frame. Now explaining a bit about the architecture. The architecture consists a series of bottleneck layers in the encoder part with squeeze and excitation blocks. These squeeze and excitation blocks are basically attention blocks to focus on relevant features by recalibrating the importance of each channel. Now, uh, the after the downsampling part, we arrive at latent space. We upsample from this latent space using classic unit decoder. But the catch over here is we are adding MC sampling at inference step. MC sampling will basically calculate variance in predictions, uh, and hence it will tell us if there are any outliers in predictions, basically to quantify uncertainty. Uh, and additionally, adding on to that, also the position of dropout layers is yet to be determined. That where we strategically place dropout layers so that we don't overfit and also not lose valuable features. My colleague Lewis will explain a bit more about methodology.
I would also like to add that we are currently facing challenges relating to the architecture because we are using MobileNet v3 small encoder. And in that particular architecture, we have 11 bottleneck layers, which will connect with the skip connections to the upsampling part. So we are still making tests to figure out where exactly the skip connections will go and how exactly we will connect these 11 bottleneck layers to the latent space. Also, I would like to add that we are considering only the previous frame and the input, and we are not considering temporal continuity in the segmentation process because adding temporal continuity will add also computational cost to our model, and that's something we don't want. We want a model that it's computationally low cost. Finally, for the future steps, we will identify gaps in data augmentation and explore bit analysis for precise end systolic volume and end diastolic and systolic volume estimation and end diastolic volume estimation. We will, like Harshal mentioned, we will also configure attention blocks with bottleneck layers and determine the optimal locations for the dropout and sampling blocks. And finally, we will test the model on the EcoNet pediatric dataset, which will provide us insights into its potential impact on individual health outcomes. Because nowadays we are making all the tests, nowadays we're making the test, not all of them, using the EcoNet dynamic dataset. So we would like to move on using the EcoNet pediatric datasets. Please go ahead, Harshal.
Yeah, and finally, the acknowledgements. We would like to acknowledge the motivation for this poster presentation was stemmed from the work carried out in the course Advanced Robust Machine Learning for Interdisciplinary Imaging Science Applications, offered under the instruction of Dr. Dima Dev. Thank you. Have a good day.
Thank you.